Hi, welcome back to LeetCode. So in this video, I am going to discuss LeetCode problem 3561, resulting string after adjacent removals. So the problem statement is that you are given a string S, okay, consisting of lowercase English letters. So that means the input the string will actually have small a to till capital small Z. So you must repeatedly perform the following operation while the string S has at least two consecutive characters. So whatever we will first remove the leftmost pair of adjacent characters in the string that are consecutive in the alphabet in either order, like A and B. So if there is suppose any A B or B A, so I'll remove this pair because these two characters actually consecutive adjacent. So and we have to shift the remaining characters to the left to fill the gap. We have to return the resulting string after no more operations can be performed. So the brute force approach, what actually we can think. So like for this example one, we actually have A, B, C. First of all, I will try to apply the operation. So what actually operation I can do? So first of all, I have to remove the leftmost pair that actually adjacent. Okay, so first of all, I will. This is the first pair, A, B. So this character, these two characters actually adjacent. So I can remove. So first of all, remove this character and I will shift. So after removing this, C will present here and now C will be shifted to the left. So now only C will be present here. Now again, I will try to apply the operation. Can I actually have any pair? No. So that's why C will be our output. Got it? Similarly, for example 2, initial input string is A, D, C, B. Okay. First of all, I will try to apply the operation. So first of this is the one pair. Is this the two characters actually present in this pair? Those are actually adjacent. No, A and D not actually adjacent. So again the next pair will be D and C. Yes, this actually adjacent. Yes, C and D both are actually adjacent. So I can remove. So first of all I will remove this and these two characters will be now back. These two places will be vacant now. Vacant. So now I will shift this B to the left. So now our string will look like AB. Okay, so again I will try to apply the operation. So first of all, this is the one pair, these two character. Yes, so this actually adjacent A and B. Yes, they both are actually adjacent. So I'll remove this. So this will be now vacant bracket, and again now I actually have no more characters, so this will be now empty. So that's why for this example 2, the output is empty. Got it? Similarly for example 3, our input string is starting ZA DB. ZADB. First of all, try to the leftmost pair. This is one pair ZA. Is this actually adjacent? Yes, they mentioned that A and Z both are actually adjacent. Now you can see here. Consider the alphabet as circular. That means A and Z are consecutive. Got it? So yes, this actually this is the leftmost pair that actually adjacent. So I will apply this operation. So now this will be now empty and I will shift this all the remaining character that is present on the right side of this. So now string will look like DB. So now next pair is possible is D and B. So is D and B these two characters actually adjacent? No, not a consecutive. So I will not able to apply the operation. So this will be our ultimate resulting string. So I have to return D and B. Got it? DB. So ultimately, what actually the brute force approach we can think. First of all, we will try to apply the operation actually I can do. So what actually operation I can do? I will scan from left to right, left to right. So I will check this current. Suppose we actually have X, Y, Z, A, B. Suppose. So I'm iterating from left to right. So first of all, this will be our one pair X, Y. So I'll check that this actually a adjacent. If it is adjacent, so I'll remove this and I will create a new string. Our new string will look like Z, A, B. Correct. So again, actually, I will again go to repeat if I am able to apply. So if I am able to modify the string, so then go to step number 1 again. So if there is no change I can do, so then actually I will break from this condition. So else break from here. break from here. So this will be our answer string. Correct. So that means first of all actually we have, suppose a x y, okay, and then b, suppose. So this is our input string. First of all I'm iterating from left to right. So is this ax, is it adjacent? No. Next is xy, this is adjacent? Yes, this is actually adjacent. So I'll remove this. So I'll create a new string with ab. Got it? So I'm able to apply this this operation. So again I'll go to this step number 1 again. Now actually we have ab. So I'll check this pair. Yes, this is actually adjacent. A and b both are actually adjacent characters. So I can apply the operation. So after applying this operation, our string is empty. So I will again go to the step number 1, but this is actually already empty, so I can't apply. So I'll break from here. So this is our input string. Output string. Output string will be resulting array. Resulting string will be empty. Got it? So I will break from here. Got it? So how actually the brute force approach I actually solve this problem. So what will time study for this? So time study will be like if suppose k number of actual operation actually I can do. Okay. So for k number of times I can actually run this while loop. K number of times while loop will run. Okay. So in each operation I have to traverse left to right the whole string, left to right in worst case. So if the string length is n, so it will be big of n. So the time will be roughly k into n. Got it? Because k times, suppose I can actually apply the operation, and for each operation I have to we have to find out that particular pair that I can remove. So that's why it will take big of n time, because the length of the string is if it is n, then we have to iterate the each character. So that's a big of n. So this will be k into n. So it will obviously give us a TLE. Correct? So we have to think some better approach to solve this. So one thing you can actually observe here, suppose A, B, C, D, suppose. So what actually are ultimately doing? We have to go to left to right and find out the first pair that actually I can remove. So first pair actually I actually got this AB. So I have to check that this actually AB is adjacent or not. Correct? So if I able to if this is actually adjacent, so I'll remove this. So ultimately the string is look like CD. So you can actually store this as a stack. How? Suppose in the stack initially it is empty. So first of all I am trying currently I am here actually the character A. So is there the previous character that actually ultimately I actually have, so this is actually adjacent? No, there is no more character in the stack, so that means this is the first character. So I'll store this. Next I'll go to this B. So I'll check that whatever the previous character actually I have, that actually A. Got it? So what is the current character B? So is A and B actually adjacent? Yes. So then actually I will pop this. Okay. Next I will go to C. So there is no more previous character, so I'll store C here in the stack. Got it? Next I'll go to D. So D. So do you actually have any previous character? Yes, C. So is C and D is actually the adjacent? Yes. So I'll remove from here. Now I have to reach the end of the input string. So and our stack actually no more character. So this actually our answer should be empty. Got it? Now go to another more other example also. Suppose we actually have A, X, Y, suppose B, okay, then suppose Z. Okay, now we actually have one stack. Initially it is empty. Now I'm iterating this input string. Currently actually I have I'm in character A. We actually have any previous character? No. So that's why there is no option to apply the operation. So I'll store this A directly into the stack. Now go to the next character X. So is there actually any previous character present? So I'll check from the stack. So why actually I'm checking the stack? Why not the I minus 1? This actually 0, 1, 2, 3, 4. Because ultimately it may be possible that this A actually already removed. So ultimately we have to check the effective previous. Got it? So that's why I'm checking the stack only. Whatever the character present at the top of the stack. So this is A and the current character is X. So these two actually adjacent? No. So I'll store X here. Next I'll go to the Y. So Y, what is the effective previous character I have? That is X. And the character is Y. So is this actually adjacent? Yes. So I'll remove from the stack. Now go to the next character B. So okay, so B actually current character, and do you actually have any effect? What is the previous effective character? So that is actually A, and current character is B. So A and B both actually adjacent. So I'll remove A also for B. Next actually I have Z. So do you actually have any previous character? Because stack is empty, so there is no more previous character, effective previous character. So I'll store into the directly into the stack. Now I've reached the end of the input string, correct? So now I'll check that which character is present in the stack only. So that actually the character that actually present after this will be the character present in the resulting string. So I'll iterate one by character in the one by one character present in the stack. So ultimately this is only character present Z. So this will be our answer. Got it? So another more another example. Suppose A, X, Y, then C, E, E, then suppose G. Okay, so now stack is empty initially, and now I'm iterating each character A. So yes, A. So there is no more previous character, effective previous character. So this A will store in the stack. So this is stack. Next, I'll go to the X. So yes, the previous character is A. A and X both are actually not a previous character, adjacent character. So I'll store the X into directly into the stack. Next, I'll go to the Y. So Y, the previous character actually effective previous character actually I have actually X, and current character is Y. So this actually adjacent. So I will remove X from the stack. Next I'll go to C, and the previous effective previous character I have that actually A. So this is not adjacent. So I'll store C here. Next is E, and the previous character I have C. C and E not a, adjacent. So I'll store E. Next is G, and the previous character I actually have E. E and G, so this is not adjacent, so I'll store G also. Okay, now actually reach the end of the input string. Now what are the string, what are the characters present in the stack? So I actually have A, C, E, G. Now if I actually store all the elements, so this is stack. So first I will get Z, then E, then C, then A. So this will have a string will look like if I actually iterate pop one by one. But what will be our ultimate result? Our output should be A, C, E, G. So this is actually the expected. This is expected output, and this is actually the current output. So what I have to do? You can see that just reverse the what actually string I am getting from the stack. Got it? So if I reverse this, so I will get A, C, E, G. Both are actually equal. You can actually compare this and this. Both are actually equal. Got it? So here actually stack actually helping us to get the effective previous. Ultimately, when actually removing this X, Y, so you can see ultimately what is the string will look like. This will look like A, C, E, G. So that is the effective previous of the C will be A ultimately. So that's why if I use the stack, and I'll check the what is the effective previous character. Otherwise, in the previous approach, what actually we are using the again actually creating a new string of the after removing, and this will take the more time because I don't know what is the effective the previous character will be. So that's why if I use the stack, so I will check that what is the character present in the top of the stack, that will be our effective previous. Got it? Got it, right? So you can see in this picture, the first of all, this actually the input string, and after applying removing XY, the string will look like this. Ultimately, you can see that what is the previous character of C. This is actually A. So you can see the stack also. When I'm inserting the C, I'm getting A actually as the top of the stack. Got it? So I hope this is clear. This expansion, and now explaining the code, that will be more easy to understand. If you have any suggestion, any doubt, actually comment on that. Now go to the code. So code actually first of all I have to take one stack, that is to store the character. Now I am iterating the input string. Got it? This for loop will iterating the character of the input string left to right. So if our stack is not empty, that means we actually have some character in the previous. If we actually have some effective previous character, that means the stack is not empty. So I'll check that is this adjacent or not. How can I actually check that this character is adjacent or not? So you can see that in A and B, or when it will be the adjacent. If the index value, or ASCII value, you can actually, if you actually take the relative value, so A minus A, then it will be 0. B minus N, this will be actually ultimately 1. So you can see that the adjacent, the difference between these two characters will be 1 always, correct? If these two characters actually adjacent, right? Similarly for B and C, so B minus A I'll get 1 and C minus A I'll get 2. So if I do the subtraction of 2 minus 1, I'll get ultimately 1. So this also difference is 1. You can actually relate this problem with actually the how actually getting the output. So that means to check that this is adjacent or not, I can actually check that if the difference between this the value is 1 or not. If it is 1, that means this will adjacent, correct? And for A to Z, here actually they mention that this actually circular list. That means A and Z actually both actually the adjacent. So how can I actually get for this situation to handle? Because if I do the subtraction of A minus A, I'll get 0. For Z minus A, I'll get 25. So if I subtract 25 minus 0, I'll get 25, not 1. So how will we check that this is actually 1? So this is for one corner case, that if the difference between A and Z or two characters is 25, that means this is for A and Z only. So that time I will actually I can say that this actually adjacent. Got it? This is for one corner case. You can say that for other case also, why not possible 25? So you can say that with suppose B and Y, suppose. So this will look like B, I will get 1, and for 1 I will get 20, for Y I will get 24. So if I subtract 24 minus 1, I will get 23, not 25. Got it? 25 only possible, like maximum Z value is 25. If I have to subtract, the other should be 0. Got it? If I have to after subtraction, if I have to uh, got the value as a 25, so that's why other value should be 0 only. Got it? Because there should be all the values present in this range will be only 0 to 25 only. So if I have to got the value 25, so the other value should be only 0 only. Got it? That's why this will work fine here. When to check that this is actually A and Z or not. So that's why I first of all find what is the difference between these two characters. So whatever the character present at the top, so I will check what is the ultimate value with respect to A, and similarly for whatever the character actually currently I have. So I will take the absolute value. It may be possible that first I will get A and another, it may be possible, right? First I'll get A B or B A, both actually possible. So in this case I will suppose get 1 minus 0, I'll get 1, and for in this case I'll get 0 minus 1, I'll get minus 1. But ultimately both actually same, so that's why I'll take the absolute value. So that's why this is 1 also, this is 1 also. So that's why I take the absolute value. Right? So if the difference, the value is 1 or equal to 25, that means this actually adjacent characters, these two characters. So I'll pop the whatever character I have in the stack, and I will not store this current character because both will be actually removed from the string. Both the character, what are the current character I have and what are the previous character I have, correct? Ultimate previous character. So I'll continue from here. Else suppose this is not actually adjacent. So what will do? I will just not enter this if block, and I will store this into the current character into the stack. Got it? And ultimately after this operation, the stack will contain the will actually have all the character that actually present in the resulting string. So I actually need one answer string that actually I have to return. So initially it is empty. So if a stack is not empty, till our stack is not empty, I will actually pop one by one character from the stack and store this into the answer string. So I have already explained in the answer string it will look in the reverse order, like in this case. So it will store our answer string will look like this GECA, because this stack will actually give us the in the reverse order the last character at the first. So I will check that if the answer is not is empty, then return from here because I have no more character. If it is not empty, that means I actually have some character in the resulting string, so I have to reverse this. So I reverse the answer string because before returning this will be our expected output. So I reverse this and ultimately return the answer. Got it? So for this, what is the time study for this? Because I am iterating the input string only once. Because you can see there is no nested for loop here. So this will be big of n, whatever the input string length, and this while loop will also run big of n maximum times worst case, because it may be possible that I can't remove any character. So this while loop will run big of n times. So in reverse also it will take big of n. Got it? So for this time it will big of n. I have shared this code in the description. You can check that. And if not, subscribe. Please subscribe channel. Thank you.